Can you hear us, Xavier?
Yes, I can.
Okay. Then whenever you're ready.
Oh, okay. I think my sound problem delayed us. Sorry about that. Okay, so my name is Xavier. I work at PIONIER as the VLTI system scientist. Today, I'm going to give you an overview of the current status of operations and also talk about future plans. So very briefly, as a recap, the VLTI is the Very Large Telescope Interferometer. It allows us to combine the 4 unit telescopes, the 4 8-meter telescopes, or the 4 1.8 movable small telescopes, the 80s. In both cases, we compensate for optical path delay in delay lines before recombining the light in different ways in the VLTI Lab. So this is a view of the VLTI Lab. We have 3 instruments at the moment. PIONIER to the left in H-band, Gravity in the middle, K-band, MATISSE in mid-infrared. And I will start by giving you an update on the different activities that took place in the last months and years, actually. On Gravity, there has been many upgrade activities, starting with an upgrade on the transmission on the GRISM with a higher transmission for the new GRISM. Many works have been done to upgrade the pupil tracking system at the algorithm level, but also the hardware. The fibers have been exchanged for better stability, mitigation of the contamination from the metrologic laser. So this laser that is backscattering or in K-band is contaminating the science exposure. So there's been efforts developed and that are implemented already from October 2022 to have better signal on the scientific exposures. And also, among others, I'm not exhaustive here. Many efforts has been spent on developing the French tracker to upgrade its speed, decrease the latency, and it's still ongoing actually. On the DRS side, there have been also many developments as the instrument evolves. I'm just mentioning here the astrometric capabilities that are improved and made more user-friendly. One aspect of Gravity that has been put on hold is the Chao on-axis mode. So Gravity came to PIONIER with a dedicated wavefront sensors in infrared called Chao. There is a mode on axis that is turned to be difficult to implement because there are low tolerances on alignment actuators, and in the context of resources and also with the acceptance of Gravity Plus project, this project has been put on hold for the moment. As a recent development of Gravity and first a very important milestone for the Gravity Plus project, the Gravity-wide mode has been commissioned and is offered to the community starting in October 2022. So this mode makes use of the 2 fields that we separate at the telescope level. So at the bottom left image, you can see a presentation of the field that is split in 2, and one part will be sent, will be directed to the Gravity scientific channel, and the other part to the French tracker channels. This is done in the following way. So if you're now looking at the right figure, you can see the part of the VLTI Lab that is called the switch yard, and that we use to redirect the beams coming from the D lines in any direction we want. For Gravity Wide, we had the need to send this B beam to the differential delay lines that are the enclosures you see at the left of this right picture, these tubular enclosures, and they are meant to compensate for the relative OPD between these 2 beams. And using an upgrade of the switch yard, we are able to send these lights through these delay lines and then send them back in the Gravity field of view, as if we are merging 2 field of view into the Gravity instrument. And this is done with the periscopes that you can see. They are marked as a circle on the image. And so this mode allows us to have 2 subfields separated by up to 30 arc seconds. So before that, we were limited to the size of the single field of view, that is 2 arcseconds for the UTs and a bit more than 4 for the ATs. And so now enlarging this capability increases our capability to observe a bigger part of the sky in terms of extragalactic sources or microlensing events. So as I said, it's offered from October 2022 in P110. Only spectral differential quantities are offered at the moment, as absolute calibration of the visibility turns out to be difficult so far, and reliable so far. And we also have a science verification time in June coming very soon, so to demonstrate the scientific potential of this mode and also characterize it better. A few words on PIONIER and MATISSE. So there has been efforts to develop the bright end of MATISSE and also make use of the Wollaston prism to get a polarimetric diagnostic. For MATISSE, we had a period where the L-band dispersion was limited to one mode because of a problem of the dispersion wheel. So there was a successful and heavy intervention that resulted well to exchange a wheel bearing in the L-band cryostats. And now the MATISSE settings are back to normal. All the spectral settings are offered. So that allows us to finalize the commissioning activities of MATISSE and go toward the official delivery of the instrument to Paranal. Concerning the graph format mode, so that makes use of the gravity fringe tracker to stabilize the fringes on MATISSE and allows for more accuracy and longer exposure times on MATISSE. There's been a number of technical activities that aimed at shortening the acquisition time, improving it. Also, we deal better with recording the fringe jumps on gravity. And all these developments led to offer this mode with full capabilities on ATs last October. When I say full capabilities, I mean here compatibility with chopping, so that allows users to get the photometry and get absolute visibility on a wider range of magnitudes. In terms of UTs, the commissioning is still going on. It's scheduled to happen in the coming months, so that we are looking at the end of this integration of MATISSE in all its modes soon. I would like here to say a few words about coordination in operations. So in Paranal, we developed a scheme where we train TIOs on using the VLTI instruments as it's been done on UATs in the same way. So TIOs are trained to use to operate instruments in the second part of the night, which is freeing night astronomers to perform high-level tasks. In particular concerning troubleshooting, but also other aspects I will develop in the next slides, including imaging operations. In terms of coordination with the VLTI expertise centers, we have worked to develop communication channels. We put a wiki in place. We have this newsletter every 6 months, trying to update the expertise centers on the VLTI news concerning mainly the proposal and observation preparation. And we try to participate in the meetings organized by the expertise centers as well to keep the link. Now moving on to a mode that we developed dedicated to dedicate observations to produce images of VLTI. So we call it imaging slots, ISLs. So there are 2 of them for each period. They last typically 2 to 3 weeks. It's a mode where it's a period of the schedule where we don't have any visitor mode and no technical activity. We want it to be free to move the telescopes around using intermediate configurations to produce the best interferometric images possible. For that, we have a dedicated tool. So here we have an example of what Antoine Meron developed for this mode, for this scheme. So we can track the UV coverage filling. So this is an example of an UV coverage we got last period for YSO. So you can see the UV coverage, and on the right, you can see basically a table that tells us when it's relevant to observe in terms of LST, but also in terms of configurations that allows us to plan ahead the management of this imaging period. And so we think we definitely addressed a need from the community because we had 20 objects per period so far in P108 and P109. So that's definitely something that we will be improving and keep doing in the next periods. Now I'd like to start a part of the talk where I'm talking about developments, so things that are not yet offered for users. So we'll start with the characterization of the VLTI polarization. It's not the first time there has been an attempt at doing this, but through a collaboration with MP, we revived this activity somehow. The approach is to propagate polarized state from the VLTI laboratory to the telescopes. On the image, you can see in the middle a camera that is placed on the M2 spider arms to record these polarization vectors, input states that we send from the VLTI lab. So it's been placed between pupil guiders and metrology receivers from Gravity above the M1. And for the UTs, there is a campaign that already took place a couple of years ago. Felix Widman reported in it in a previous edition of SPIE. For the AT campaign, it has been done recently, a couple of months ago. We are in the process of analyzing the results. I can just tell you a few preliminary findings. So we find that there is overall very little depolarization along this optical train. There is definitely an instrumental polarization, and we see for the ATs that it does vary depending on the ATs you are looking at. It seems like it's working by pair, meaning that 81 and 82 are similar and different from the 83, 84 pair. So these are just a preliminary information. The modeling is going on. The idea is that we understand how the polarization is propagated, and eventually that this information can turn into useful correction and enable polarimetric observations on sky with VLTI instruments. So that this is ongoing. I will move now to a project that has been on the VLTI roadmap for a long time. So the goal here is to enable the longest baseline on the VLTI platform. So if you were to observe with the configuration you can see on this picture, in particular with the 82 in B5 and 84 in J6, the end of the platform between close to UT3. So that's 202 meters, it's the longest baseline, and you will end up with this sky coverage you can see on the right, where all the little red crosses tells you that your delay lines are too short to observe in this part of the sky. And so such a sky coverage is not very useful in operation. We wanted to improve that. So through a feasibility study, and we had an intern coming to work on this, we ended up with a design for a solution. So the idea is to use the dual beam capability of the VLTI delay line cart in conjunction with the periscope to go twice in a delay line, and that gives us twice the amount of the OPL that a normal delay line would give us normally. So let's follow the optical path. So if you look at the left picture, you are entering the delay line cart from the top right. You're exiting it from the bottom left. Then you go to the middle picture, you hit the periscope, you translate vertically the beam to pass a second time in the VLTI delay line cart. So go back to the left picture, you enter from the top left and you exit in the bottom right. So this way you go twice, you double the UPL, so you're able to compensate up to 200 meters. And this light is then directly transferred to the VLTI lab with the M16s. So this is a periscope that has been put on a bar, on a sliding bar, as you can see on the very right picture. There are also proximity sensors that allows us to know the software, supervisor software of VLTI tells us with these proximity sensors if the periscopes are in or out. So that allows us to have a good communication with the software for managing the delay line. So we get a bit of delay with the COVID, the manufacturing of the mirror, and it took a bit of time. We got them assembled in October. We had the first test period in December, where we were able to check the main functionalities, and we got some surprises and things left to do that we didn't expect. But observations are successful on the longest baseline, so we check that. So this is an example on the right, a figure of the gravity fringes found on the longest baselines and the largest quadruplets. With all these additional reflections, so that's 7 more reflections with protected silver, we get transmission loss inevitably of 20–25%. So that means a limiting magnitude that it is decreased by 0.25–0.3 mag. So we still have a bit of work to do concerning software. We want to make the operation as fluid as possible. So we will do that as soon as possible from October 2022. Okay, so now I'm going to talk about Gravity Plus, which is going to create a major change at VLTI, upgrading the facility, boosting the sensitivity up to K=22 in an off-axis mode. Gravity Plus consists in several things. So I talked about gravity wide, I talked about the instrument upgrades, and the Gravity Plus will bring major facility upgrades for VLTI, starting with visible adaptive optics called GPIO. From 2033, it will replace the existing adaptive optics that we have at the moment, Macao. It will be based on the Iris design, inspired by the Iris design. Gravity Plus will also bring laser guide stars, UT1, UT2, UT3, UT4 already has one, as 4, but Gravity Plus will make use of one of these 4 for UT4. But de facto will bring laser guide stars that are readily available for UT standalone instruments if they need to be upgraded with adaptive optics. So that's a good plus, a good bonus to VLT from the Gravity Plus project. And we are also going to recode the UT coded train to improve the transmission in synergy with the High5 projects that Denis will cover tomorrow. We'll talk about tomorrow. We want to better track the vibrations that are critical for high contrast and high accuracy at VLTI. And so new accelerometers will be put along the M4 to M8 coded train. So in terms of status, Gravity Plus passed phase day last year. Agreement was signed earlier to give the green light to go ahead. I told you Gravity Wide will be offered soon. There are reviews quite frequently to follow up on this project. We had one in February to talk about the design of the AO, discuss interfaces. And for Parana, this is already quite real, this project, in terms of technical activities. There are many activities that are taking place now to ensure gravity and the infrastructure are evolving towards gravity. So it's important work of coordination we are doing at the moment to allow these developments while also making sure the system is stable enough to produce a good scientific data. Talking about the visiting instrument scheme now at VLTI. So it's a scheme that exists also on UT, but at VLTI, it allows to reach unique performances with new techniques and new instrumentation in a relatively short time scale. So instead of going through all these reviews and having heavy constraints in terms of hardware and software, there is this scheme where things can be done in a shorter time with limited support from ISO. That's the counterpart. So to allow this, work has been done on the interface control documents to prepare the offering of 2 VLTI foci. That has been done from 2019. So following the decommissioning of Amber, we freed this large table that you see in green on the figure, on the graph. And there are also 2 other volumes that will be available for this below the Pioneer table. So you will hear a lot about this visiting instrument tomorrow in the rest of the session 6, in particular with the Asgard suite of instruments has now engaged in this VIA acceptance process. So looking forward to hearing about this tomorrow. Here, I would like to tell you about something a bit internal, but that's good to talk about. It's a good contextual information. So you know, VLTI is coming. Paranal is looking at a way of operating VLT with VLTI and ELT and potentially also CTA in an integrated way, meaning that the resources for operating these three facilities have to be lower than the sum of individual operating individually these three facilities. We have to mutualize somehow. So there's a big work that's being done at the moment to map the different processes and the resources we have. For VLTI, we have Gravity Plus. We have some visiting instruments in the pipe. There are also VLT projects coming to Paranal, so we really need to make sure we have the resources for the timing of all these different projects happening at the same time in Paranal. There is a dedicated group that is now that has been formed in Paranal using system engineering approaches. And for operations, it means that we are looking at linear operations, meaning we try to identify the waste and also improve the remote observations, but also not compromising with the high performances. It means that we are looking at improving the automatic presets, making automatic acquisitions, also observation selection and execution. There are projects to use machine learning techniques to improve scheduling strategies and forecast predictions. There are many other aspects, monitoring of performances, quality check, etc. Just to tell you that efforts in Paranal will be put in this direction from now on, and for until this model of integrated observatory is reached. I'm not sure how long I have, but I will be fast. So if we take now a look back where we are in terms of VLTI roadmap, so we are in this second epoch, 2025. We are definitely in the middle of this phase of hosting visiting instruments, upgrading instruments, upgrading the facility. And if we are not looking at the third epoch, which is about expanding the facility based in a community chosen direction, we know the community is very lively. So we had this conference in 2019 to prepare the future of VLT with the VLT 2030 conference. So Gravity Plus was presented there, Visiting Instruments Project was presented there. And more recently, more recently, through a bid to a European grant, 13 projects for future VLTI instrumentation were also presented. So I'm not going into the details, but they covered instrument upgrades, the case for more telescopes, going to visible wavelength. So there's all these discussions that are, all these ideas that are in the community at the moment. And the question also of whether we should look at a facility upgrade or maybe there's a need for a new facility are also happening. So we are in a very interesting time, and I think the community is ready for the, or at least have a lot of like this for the post-Gravity Plus era of VLTI, and we need to discuss and converge to find this future together. So as a conclusion of the last 2 years, we definitely going forward to the conclusion of the second generation of instruments at VLTI. We've been trying, and we are in a good way to increase the VLTI observation space. So in terms of limiting magnitude, I didn't tell you, but we had also an increase of limiting magnitude with the Naomi adaptive optics, both on the AET, sorry. So that was in 2018, 2019. We increased the spatial resolution with the offering of longer baselines, increased sky coverage. Gravity Plus will be transformational for VLTI. boosting its sensitivity. We have many projects to bring new technology, new techniques at VLTI to bring new contrast, high contrast capabilities and higher spectral resolution that VLTI has ever seen. So lots of interesting science, lots of interesting instrumentation to be considered. We are also in the context of resources, limited resources in an integrated observatory. So all of this will work well if we are good in terms of timing and coordination. That's my conclusion, and I will just finish on this advertisement. Maybe it has been done this week already, I'm not sure, but it is to advertise again this VLTI session at the EAS to celebrate the 20th anniversary of the VLTI fast fringes. You can see one of the siderostat that were used for that with the serious fringes done with this siderostat to demonstrate the principle of VLTI. Thank you.
Yeah, thank you for the talk. Any questions? Yeah.
Hello, Xavier.
Hello.
Romain Petrov from University of Nice. I have many questions, but one, in your extension of the delay line where you make a double pass, how is this compatible with the the double field things?
It's not, gravity wide is not compatible with delay line extension. So okay. It's, yeah, so we plan to use the delay line extension only for the extended configurations that we are going to offer. There is a gain, there could be a gain for the astrometric configuration. We gain a little bit, but considering the operational aspects, it's not really worth it. So the extension will be only used for the longest baseline.
And I have a second question about Chao. You said it's difficult to put it on axis, but now we have more and more possibility to work off axis with gravity and also with graph format. Would this be a solution? So you fringe track without Chao on one axis and you have the science observation with Chao on the other axis, even for Matisse?
So we can't, you want to fringe track on Chao? Sorry, you want to use Chao on axis?
Well, so that means my direct problem is that I cannot use Chao with Matisse.
Yes.
Because, and the reason why is that it cannot be used on axis, and Matisse so far was only on axis. But in the graph format mode, we could have a fringe tracking object on one axis, and the science instrument, which is Matisse, and which needs Chao because it looks at very red objects, on the other axis. So would that be a solution to use Chao with Matisse without having to implement the changes implied by using it on axis?
So you want to use Chao off axis? That's the question.
Yes.
Is it possible to use Chao off axis? Because there's no way at the moment Chao on axis can be delivered, even for gravity. So it cannot work for graph format. So the question is whether you can use a graph format off axis. Sorry, Chao off axis with the graph format. So as long as you let me think. So so you block the beam B, so there's no propagation. But if you have, yeah, that should be possible. I don't see why not.
Good, then that's a solution. Well, we have to rediscuss, I think.
Yeah, maybe at another time where I'll be less tired. It's 1 AM where I am. Maybe I'm not seeing clearly. But yeah, okay. I will think about it.
Okay. Any other quick questions? Yep.
Hi, Xavier. This is Denis Defray from Leuven. Can you comment on the status of the dark hole mode of gravity and when we expect this mode to be offered?
No, I can't really. I'm not the expert of that. I just saw it passing as a technical activity. I know it's a very interesting opportunity to get rid of the speckle and using the deformable mirrors of the 80s. and also as a sort of a step before the same thing happening on the DM with the UTs. So I know this is in preparation in order to observe better the exoplanets next to a bright object, but in the details I will not be able to tell you much. This is I don't think we had the first try of that, or it's happening this week or this month. It's coming soon, but I don't really have a good view of the results on this.
Okay, no problem.
Okay.
I think Felix is around. You must know about this. You must have a lot of gravity people in the room. So I'm deflecting this to them. Sorry.
Okay. Well, thanks again.